Hey everybody, welcome to the next video for the course. This video is about simulating randomness, by which I mean how can we ask the computer to simulate random numbers for us. So in particular, the main question that we'll focus on is how do you get C++ to generate a random number for you inside of a given range, like a random number between 1 and 100, or 1 and 50, or 2 and a billion, whatever. And then I'll show you an application of such a thing to games. So let me just say that it may not be immediately obvious why being able to simulate randomness is important, but it is incredibly important. And in particular, if you think about writing game programs, it perhaps is obvious why this sort of thing is important. You know, any sort of card-playing game, you have to shuffle the deck of cards, right? And that involves some sort of randomness. Or think about writing any sort of game program, cards or not, where maybe the computer is supposed to act like an idiot, like an easy mode. The easiest way to write an easy mode is for the computer to just make its moves at random, right? You tell the computer, no strategy, man, just make a move at random. You know, that's what an easy mode might do. And so to make a move at random would correspond to choosing a random number somehow. Also, I do a little bit of the mathematics of voting, and if you want to get sort of a baseline of how voters might act, you can write a computer program that says when a voter shows up to a voting booth, they flip a coin between Republican and Democrat, which is kind of like choosing a random number, 0 or 1, or however you want to encode that as numbers. And then what you do is you simulate that for every single voter, you know, get the aggregate data, see who won, and then you can simulate a new election and do this over and over again. That sort of gives you a baseline for how people will act if they're acting randomly. Anyway, so it's incredibly important to be able to teach a computer how to choose things at random. The way that you get a computer to choose things at random is with what's called the rand function. What that does is it generates a random number between 0 and 32,000-ish. I'm not sure exactly how high it goes, but something like that. Okay, the problem with what I just said is that it's a lie. So I try not to lie to you very often, but this first sentence, while basically true, is not technically true, okay? So what actually happens when you use the rand function is it goes to a random number table that's built into the computer, and it just looks inside there and tells you what it sees. In particular, this function just goes to the same place inside that table every time you restart the program. So just to give you a taste for how this goes, sorry, I should have said you need this header file if you want to do this, so include a random there. Anyway, so I can ask the computer to print what it thinks rand is. What is that right now? So it's going to print to the screen a random number between 0 and 32,000. And there it is, 16,807. Okay, suppose I start the program again. Like, hey man, generate a random number for me. It generates the same one, okay? So it doesn't matter how many times I restart the program, it's going to print for me 16,087. That's bad. That means it's not really simulating randomness at all, right? If it were actually simulating randomness, it would give you a different number every time. Or probably, right? Probably give you a different number every time. So the question is, how do you actually make it sort of simulate randomly going inside that random number table? You need a process called seeding. And let me just tell you how that works. There's a function called srand, and the S stands for seeding. And you put an integer inside of it, and it starts reading the random number table at the seed position specified by this integer. So if you say srand 10, that means that when it goes inside the random number table, it's going to start reading at the 10th number. So if you put a 30 in there, right, that would mean go to the 30th entry inside the random number table. So ideally, every time you run the program, the seed should at least possibly change. You know, it shouldn't stay the same every time. So an easy way to do this is to seed by time. So if you do time null, what that means is it's going to go inside the random number table to the entry that corresponds to the number of seconds since January 1st, 1970. Okay? Now, it's not important to know that. What is important to know is that if you're seeding based on that, that means that every time you start the program, you'll be going to a different place inside the random number table because the number of seconds since this time has changed. Okay, so all of that to say, in the actual code, to do the seeding by time, you need a new header file called ctime. So we have two new header files now, random for the randomness, ctime in order to seed the randomness, and that command looks like this, srand time null. So anytime you want to actually simulate randomness, you will just start your code with this command. That will make it so that when you start the program again, you'll get potentially different answers. So let me run this. Now it prints something huge. Okay. Something huge again. Yeah, so what's happening here, sometimes it behaves strangely. Forget about the first few digits. Focus on the last few digits, like 61009. Focus on that. That's changed now to like a 29079, which has changed to a 13114, etc. So I'm not sure why it gives you the same nonsense at the front, okay? But all that matters for us is the tail end is different. So it's actually giving you different random numbers. That's the point, right? Something different. Okay, so now let me return to the original question I told you we were interested in, which is given two numbers A and B, like 0 and 9, right? How do you generate a random number between them? So, if you want to simulate throwing a die, right, tossing a single die, you would need to generate a random number between 1 and 6, for example, right? Okay, so how do you do that? Well, let's think through what would happen there. The numbers 0 through 9, for example, right, 0 through 9, that represents all possible remainders when you divide by 10. Okay? So if you take any number at all, 13,445,000,000, whatever, right? Any number at all, when you divide that number by 10, there are only 10 possible options for the remainders. You can get a remainder of 0, which means that your number was a multiple of 10, or you can get remainders 1 through 9. You weren't a multiple of 10. Okay, so by the same token, if you were dividing by 6, there are only 6 possible remainders, 0 if you're a multiple of 6, up through 5. Okay, so if you want to generate a random number between 0 and 9, you can use that to your advantage. So generate a random number of any kind, doesn't matter, then take its remainder when you divide by 10. Since the only possible remainders are 0 through 9, what's guaranteed to happen from this line of code is some number between 0 and 9. So let me come back here and do %10. So now what I'm saying to the computer is, generate some random number for me. I don't care how big. And then when you're done, divide that number by 10 and record the remainder. And that's what it will print. So now it prints 5. Okay, that's a random number between 0 and 9, and it's a possible remainder when you divide by 10. 1, right? 5 again, 9, etc., right? These numbers will always be between 0 and 9 because you're forcing it to take remainders when you divide by 10. Okay, so that's how you can generate a random number between 0 and 9. Just generate a random number and then do the percentage symbol 10 so that you reduce. You get remainders rather than the raw numbers. Well, what if we wanted something else? What if we wanted 1 to 10, not 0 to 9? Well, if you think about it, we already know how to get something random between 0 and 9, right? So the relationship between 0 and 9 and 1 to 10 is that you just shift things up by 1. So let's just do that. So this first piece here will give you a number between 0 and 9. So then just take whatever number you got and up it by 1. And you are guaranteed to land in the range 1 through 10. Okay, so let's just do that to confirm. So 4 is a number between 1 and 10. 8 is a number between 1 and 10. 2 is, etc., right? See if we eventually get a 10. Yeah, so we got a 10 here, right? So 10 is a number between 1 and 10. We couldn't get 10 before without this 1 plus, because without that 1 plus, 10 is not a possible remainder when you divide by 10, right? 9 is the largest possible remainder when you divide by 10. So this 1 plus, what must have happened was, whoa, don't know what happened there. This right here must have generated a 9 for you, a remainder of 9, and then you kicked it up by 1 to get you 10. Okay. So what if you have some other range? I don't know, 12 and 21, right? How would you think about that? Well, we can just take what we did, right? This is still saying give me a random number between blah and blah, and there's 10 options, right? 12, 13, 14, 15, 16, 17, 18, 19, 20, 21. 10 options, right? All in a row. And those 10 options start with 12, right? Just like these 10 options start with 1. So now you can just take what we did for 0 through 9 and shift things up by 12. That's all this is doing. So the exact same idea, just up that range by 12. So now we're saying, hey computer, choose me a random number between 0 and 9, please, and then take the result and up it by 12. So now we get things like 20 or 14. Okay, so let's think about why it's saying 14. What must have happened was this little piece here gave you a 2. 2 is a number between 0 and 9. Oh, and then you upped that 2 by 12 to get you a 14. Okay. Etc. Okay, so to generate a random number from 10 consecutive numbers, starting with the number A, this is the line of code you need. So give me a number between 0 and 9, and then up it by A when you're done. Okay, what about random numbers between 0 and 4? That's not 10 consecutive numbers, that's 5 consecutive numbers. So how would you deal with that? Well, when we were doing 0 through 9, right? 0 through 9 are the possible remainders when you divide by 10. Well, 0 through 4, what are those? Those are the possible remainders when you divide by 5. If you have a remainder of 0 when you divide by 5, that meant you were a multiple of 5. Otherwise, you can have remainders 1 through 4. So here's how you can choose a random number between 0 and 4. And then if you want to generate a random number between 11 and 16, that's 5 numbers in a row, right? 11, 12, 13, 14, 15. Oops, 16. Miscount. Sorry, that should say 12. That's my fault. It should say 12 right here, okay? Between 12 and 16, right? 12, 13, 14, 15, 16. What you would do is up things by 12. Sorry, I should say 12. So let's come back over here to the code. I want to choose a random number between 12 and not 21 anymore, but 12 and 16. Oops, sorry. 5 is what I said, right? So 16 comes out, 12 comes out, 14 comes out, 13 comes out, etc. Okay, so again, let's think about why would you get a 13 here? Well, this little chunk of code right here generates something between 0 and 4, and then you up it by 12. So this chunk of little code here must have given you a 1, and then the 12 plus gets you up. Okay, so in other words, this same pattern will hold no matter what percentage number you're doing here, percentage 5, percentage 10. So the punchline is, and this is something you'll have to know, you'll get used to it after you do it a few times, to generate a random number between A and B. What you have to do is first choose random numbers between 0 and something, and that something is actually B minus A plus 1, and then just shift things up by A. Okay, so let's remember this, B minus A plus 1. So endpoint minus start point plus 1. So when we go back up here to 10, how would you have anticipated a percentage 10 right there? Well, 21 minus 12. What is that? That's 9. So you add 1 to that to get you 10. That's why there's a 10 right there. And then, sorry, again, this should be 12 and 16. Okay, 12 and 16. How could you have anticipated a 5 right there? Well, 16 minus 12 is 4. Adding 1 to that gives you 5. Okay, so this is just a random, this is a line of code to know. Here's how you generate a random number between two given numbers, including those two numbers, right? So every time I've been saying the word between, I mean inclusive between. So you can hit A, you can hit B, you can hit anything in between. So just for another example here, right? To generate a random number between 11 and 35, how would you do that? We'll just take 35 minus 11. What is it? That's 24. Then add 1 to that to get you 25, and then shift things up by 11. So this line of code here will randomly choose a number between 0 and 24. the possible remainders when you divide by 25. So this line of code gives you something between 0 and 24, and then you just shift that number up by 11. So if you generate a 0, 11 plus 0 is 11, so you can hit 11. On the top end of that, the biggest possible remainder is 24, and 11 plus 24 is 35. And then you can hit anything else in between. Okay, so just to show you an example of how this might go, let's simulate rolling a couple of dice 10 times. So, okay, I'm going to do something 10 times, so let me use a for loop to do that. So for loops are nice for when you have to do something a fixed amount of times. So now, no matter what I put inside of this for loop, it's going to run 10 times. It starts at I equals 1, goes up to I equals 10, and it goes 1 at a time. Okay, so how could I simulate rolling 2 dice? And I guess what's implicit here is that, yeah, let's just roll the 2 dice and see what they look like. Okay, so I have a couple of dice. Okay, so to roll die 1, what does that mean? I need to choose a random number between 1 and 6. Okay, so between 1 and 6, let's go back to our formula here. 6 minus 1, that's 5, plus 1 is 6, and I start at 1. So when I roll die 1, what I'm doing is I'm taking 1 plus rand percentage 6. And then die 2 is the same. You're also just choosing a random number between 1 and 6 to roll that die. And then if you want to see what happened, we'll just print them. Okay, so what happens is every single time this for loop runs, you're essentially just rolling the die, right? You're rolling the first die, rolling the second die. Every time this code runs, you'll choose a different, potentially different random number. So let's just see what this does. Okay, so the first time I rolled a 1 and a 6, second time a 3 and a 4, third time 5 and a 4, fourth time 5 and a 2, etc. So there's how you can simulate rolling a couple of dice. And then if you wanted to, like if you wanted to measure their sum, which is something people do a lot of times, right? Like when you play a dice game at the casino or something, you're not just looking at what the die individually say, you're adding them up. So we could also just do that, just read off the sum if you want. It all depends on what you want the code to do. So here we're going to simulate 10 rolls of the dice with their sums. So now we get numbers between 2 and 12. So we rolled a 10, rolled an 11, a 9, a 4, a 3, a 7, 6, 10, 10, 6. Okay. So anyway, being able to simulate random numbers means that now we can program any sort of dice throwing game, right? Like craps or, I don't know, Yahtzee or something, whatever. Okay. Yeah, so this is a cute question. How can you generate 3 different random numbers between 1 and 10? Okay, what would that look like? So it's not even clear that that's a well-posed question, but let me give you an idea of what that looks like. You want to choose 3 different random numbers, and they're all between 1 and 10. So let's just create storage spaces for our 3 random numbers. Okay, so let's first just generate x. So x has to be a random number between 1 and 10. So that's 1 plus rand percentage 10. Okay, so x has now been chosen. So if we print to the screen x, right, it's just going to tell us whatever. It's going to tell us like 7, right? Okay, once you choose x though, this thing says different, right? So you could now do this in the code. You could say, well, y is also a random number between 1 and 10, right? But y could be x, right? If x is 7, y could also be 7. We haven't done anything to prevent that. So what you could do is like this. Generate y, and then say if x and y are the same, then, you know, you better choose y again, right? So we've chosen x. Now let's choose y. If they happen to be the same, well, let's just roll the die again, right? A 10-sided die this time. Choose y again. The only problem here is that, let's say x is 7. Y could also be 7 after this roll. Y could also be 7 after this one. Okay, it's not terribly likely, but that could happen. Okay, and then once you get to the end of the if, you're screwed. You didn't do what I asked you to do. So what you really want to do here is this. Hey man, as long as x is the same as y, then keep choosing y for me over and over and over again. Okay? So I'm going to choose x, I'm going to choose y. If that y happens to be x, then I'm going to enter this loop. And I'm not leaving this loop until y is different. Okay? Because the loop loops, right? As opposed to an if statement where you escape after the first pass through. Whoop, I should have asked it to print. Okay, so now no matter what, whoops, what did I do? Oh, that. No matter what now, these two numbers will be different, 6 and 5, 7 and 2, 4 and 1, okay? They are different precisely because that loop is there. As long as x and y are the same, you're not leaving, you know? And then once you've left, that must have meant that y was different, and so now the two numbers will be different. Okay. So now we've chosen a couple of different ones. Well, you're supposed to choose 3 guys that are different, right? So we can do the same thing down here. We've chosen x and y. X and y are different. So let's just sort of roll the die for z, choose it, and then what you want to say in English is, well, if z equals x or z equals y, right? If it's either of the two things you've seen before, then you would need to choose z again, wouldn't you? But just like before, it's certainly possible that z equals x at first, right? So z equals x at first, so we go in here, and then, oh, after you re-roll z, it equals y now, or something, you know? So it's possible you escape this if statement without actually doing what I asked you to do. So what you really mean is like, hey man, as long as z is x or z is y, please keep re-choosing it, you know? So now you can't break out of that loop until z is different from x, z is different from y. Whoops. So at the end here, let me just print all 3 of them, and we will notice that they are all different. 1, 6, 8. 5, 4, 10. 9, 5, 10. Okay, they will always be different because of these loops I've put in there. Okay, so if I take these loops out, it's certainly possible you'll get some overlap. Whoops. Okay, so now the loops are gone. So all I'm doing is choosing x, choosing y, choosing z. Let's see what it prints now. 7, 3, 9, so we got lucky that time. 8, 3, 4 got lucky. 5, 2, 10 got lucky. 9, 10, 9, right? So without those loops there, it's certainly possible that you get the same thing, right? So those loops are what are forcing this thing. Like if it generated 9, 10, 9, it would have to choose z again, right? Because z matches x, so it will have to go again. Okay, so you can choose random numbers to simulate dice throwing, right? You can, if you want to, you can make sure those dice give you different outcomes if you need to, you know. You can make sure that things are different. The last thing I'll tell you is that simulating card dealing rather than dice throwing is also fairly straightforward. You just have to encode your cards as numbers. So you could, for example, randomly generate a number between 1 and 4 to represent suit. So you could think to yourself, okay, so clubs will be 1, diamonds will be 2, hearts will be 3, and spades will be 4. And then once you've generated a suit, you could randomly generate a number between 1 and 13 to represent the card value. So 1 might be ace, 2 will be 2, 3 will be 3, and then 11 will be jack, you know. Or there are just 52 cards, right? So you could just assign each card its own individual number and generate a random number between 1 and 52. You know, it's up to you, but all of this to say that you can also generate randomly chosen cards if you encode them as numbers. Okay, so at the end of this video, the main takeaway from this is really this formula, right? Here's how you randomly generate a number in a given range. And then once you're able to do that, you're able to do all sorts of things like simulating dice throwing, even simulating different random numbers if you so choose. and doing things like dealing cards. Okay, so that concludes the video on randomness.